Alright, today we're going to be solving Paula Daurat's equations. This is for stoichiometry. For the first question, we're going to start by writing out the table. NaCl plus lead nitrate turns to N3 plus BBC. Now what we're going to be doing is writing out the table now to solve for mass of lead chloride, which is this, with a 90% yield rate. Now we're getting 4 grams over here, and we know the molar mass from the periodic table. How we find this out is, for example, NaCl. We find out the numbers from the periodic table, multiply it by its coefficient, and this will give us, let me add them together. So for sodium chloride, it's going to be 58.44, and for lead chloride it's 278.09. Now with the stoichiometric triangle, mass over molar mass gives us mole. We can find the moles of sodium chloride, which will give us 0.068. Now you'll notice for the ratios that they're all 2, 2, 2, 2. That means for 2 moles of sodium chloride, we get 2 moles of lead chloride, which is basically the same amount. Literally the same amount, so we're going to write that down. Now that we know the moles, and we know the molar mass, we can find the mass. And we find that out by multiplying moles and molar mass. If you multiply 278.09 into 0.068, you'll get 19.03 grams. But you'll notice there's a 90% yield. That means 10% was lost through errors such as like losing some on the equipment or whatever. And we're going to multiply the theoretical with the percentage yield to get the experimental yield. So 19.39 into 90 over 100 is 17.13. You can also write this as 0.9 grams, which is the final answer. Alright, so to the second question. Let's write the table. Mass, molar mass, moles, ratio. Write it down. What are we given? We are given 30 grams of sodium phosphate. Sodium phosphate is here. And excess calcium nitrate. Now calcium phosphate was precipitated, and 25 grams were recovered. This is the experimental. We don't write this down. We need to find out, this is the theoretical. We need to find out the theoretical and then the percentage yield. So what we're going to be doing is by plugging in the molar mass as before, by adding up the elements in each compound. For sodium phosphate, it's 163.95. And for calcium phosphate, it's 310.18. To find the moles of sodium phosphate, we divide it from the triangle as we divide it. So it's going to give us around 0.183. And the ratio is 2, 3, 6, 1, 2 to 1, since this is what we're interested in. As it's 2 to 1, for every 2 moles of sodium phosphate, we get 1 mole of calcium phosphate. This means as we're going a big number to a small number, we'll divide it by 2. That will give us 1 which is around 0.09145. And now we know the moles, and now that we know the molar mass, we can find the mass, and we multiply them. Multiplying 310.18 with 0.0915 gives us 28.38. This is the theoretical yield. To find the percentage yield, we take the experimental yield divided by the theoretical yield into 100%. So multiplying 25 over 28.38, we don't multiply, we divide it, into 100% gives us 88.09%, which is the answer. Alright, for the next question, mass, molar mass, and ratio. We can plug in the ratio immediately. So, we are given that calculate the theoretical mass of iron that could be recovered from 500 kilograms. 500 kilograms is 5,000. Well, let's just keep it 500. Suppose that 308 kilograms of iron is actually recovered. This is the theoretical, experimental, and we are going to use this later. What we actually need to find is this, the theoretical, to compare it with the experimental. And then we can find the percent yield as well. So, we're going to find the moles of iron oxide, which is found from the molar mass. 231.53 molar mass. To find the moles, we divide it. So we're going to get around, converting kilograms to grams is we multiply it. So it's going to be 500 into 1,000 to convert from kilograms to grams, which will give us around 2,159.6 moles. As the molar ratio is 1 to 3, so we're going from a small number to a big number. We're going to multiply it by 3, which will give us 6,478.8. And the molar mass of iron is 55.85. Now that we know the moles and the molar mass, we can find the mass by multiplying them together, which will give us the 361,800 grams, which is around 361.8 kgs. Now that we know the theoretical yield, we can use the experimental yield to find the percentage yield. So the experimental yield was 308. Our theoretical was 361.8 into 100 gives us 85.13%, which is the answer. Alright, after this, one more question to go. First, the chemical table. Mass, molar mass, moles, ratio. Alright, what are we given? We are given that the mass of wintergreen can be produced from 100 grams of salicylic acid, assuming 75% yield. So, we are trying to find how much of this can we make if we are given 100 grams of salicylic acid. Well, First, we're going to plug in the molar mass from the periodic table, which is 138.12. If you divide 100 over 138.12, you'll get 0.724. And for wintergreen, it's 152.15. Now, as the ratio is a 1 to 1, well, everything's 1, so we can just transfer it directly, 0.724. Now that we know it, we can find the mass. We know both of this. We multiply them together, standard protocol, which will give us 100 grams, 110.1 grams. Now, we also know that there's a 75% yield, so you're going to have to multiply it by that to get 82.67 grams. Oh my god, okay. Cool. Let's start. Usually we're supposed to check if it's balanced. I'm just assuming it's balanced because it's a worksheet, not a test. Usually these worksheets tend to be balanced already. They wouldn't be that harsh. Alright, so what are we given? We were given the process only 80% efficient. 1,000 grams of SO2. So we're trying to find this now that we're given that. The ratio is 1 to 1, 1 and 1. So you can find the moles of this. Take that. Alright then. The molar mass of SO2 is 64.06. The moles is 15.611. Transfer it directly. Same moles. The molar mass of calcium calcium oxide is 74.09. Multiplying these numbers together will give us 1,156.4 grams. That is the theoretical number. The actual, now that the process is only 80% efficient, we're going to take the theoretical, and as the process is only 80% efficient, what that means is that we'll need more calcium oxide because it's less efficient, so we need to use more to make up for it. We can take the theoretical and divide it by the efficiency to get 1,445.91 grams. And that's it.